So it is an intensely pertinent question that what is gravity? All right. So gravity is the electromagnetic force matter exerts on the universe on dark energy that causes a dark energy field effect or gravity. All right. Gravity is not a pulling force. All right. Gravity is matter pushing away space itself, and it's space pushing back that causes all matter to appear to have self attraction. But in reality, it is space itself pushing all matter together. Dark energy is space, and space is dark energy, what we perceive as empty space. So that empty space which we perceive is not empty nothingness. Rather, the vacuum of space is actually full of energy. This goes from the deepest voids in the farthest reaches of outer space to the space in between the parts of the atom. This quote unquote empty space is actually full. It's full of energy. It's not detectable by most standards, but the energy is there. And it does exist. It reveals itself from the random fluctuations of electrons popping in and out of existence to the excess of heat in the deepest reaches of outer space. The energy is there. It does exist, and it is the cause of both gravity, matter, and what we call regular energy. All matter in the universe, from the stars to the planets, rocks, moons, sand, air, and fire, also organic matter, all this matter in the universe is giving off electromagnetic radiation in some form or another, which is matter decaying. And it's this very decay of all matter and energy in the universe that creates dark energy or space. So all matter is decaying into more space. There are huge equations involved in the decay rate, and the thermal and fluid dynamics are a direct indicator of this interaction. So I will elaborate this more in upcoming videos, but just understand all the energy and matter in the universe is slowly decaying into more space, and this is why we see the galaxies moving away from each other as they decay. They literally create more space between themselves. So if dark energy is space and its dark energy that is causing gravity, then what is the actual meaning of gravity? Well, it's exactly what Einstein called it. So, gravity is the curving of space time. But what does that mean, and how do we take that concept and quantize it? I will not get into the straight line is a curve argument that nobody can understand, alright? But I will quickly acknowledge that based on the very nature of the universe, everything is literally curving as it moves through space. The planet is curving, the sun is curving, the galaxy is on a curve, the atoms and the flows within the atoms all are curving. The curve I want to talk about is a curve on a graph which you can draw. So you have to think of curve as a calculation. Think of it like this. From 10 feet away, you feel the fire on your face. Alright, a candle is lit, and when you're 10 feet away, you just feel the fire on your face. But at 5 feet away, its intensity is not exactly double, but it is warmer, and at half a feet away, its intensity is extremely hot. Do you see this? If you were to plot this on a graph, you would say, okay, shorten the distance by half and you only get about one third more heat. But if you shorten the distance again, you get 99% more heat. These values are examples. So on the graph, you would have a curve form, and this is the idea behind curving of space-time. So what is space-time? Space-time is called space-time because this curve not only affects gravity or the perceived force of gravity, but also time as well. So you can say there is a curving of both gravity and time if you were to be in a stationary object orbit in relation to your current position on the surface of Earth. You would not only feel less gravity, but you would have more time. Your time would still feel like regular time, but the watch on your wrist would be ticking faster than if it was on the surface. To you, a minute would still feel like a minute. But if you were up there for an hour or so and you came back down to Earth, you would see that more time than an hour had actually passed on your watch compared to an identical watch of someone who is on the surface of the Earth. So you have less of a gravitational pull, and your time is faster when you are about 1,000 miles above the surface. When we think of space time and gravity, we could say that there is more space 1,000 miles up, and so there is more time too. That is the idea behind space-time, and the curve is just like the heat from the fire. At 500 miles from the surface, you feel more gravitational pull than from 1,000 miles, but not exactly double. And at 50 miles, you feel 99 of the gravitational pull. So, if space and time are tied to each other again, space or space time is not empty nothingness. Space is dark energy. So, if you were to say at 1,000 miles above the surface, you have more space time. What you are actually saying is at 1,000 miles above the surface, you have more dark energy. So, what is gravity? Gravity is the electromagnetic energy that matter exerts on the universe on dark energy that causes a dark energy field effect or gravity. What this means is that matter is pushing space time or dark energy away from itself, and it's this force that has a curve to it. So at 1000 miles above the Earth, the pushing force from Earth is only so strong, and at 500 miles, it gets stronger, but not twice as strong. And at 50 miles, the pushing force of Earth is basically full strength, and so you basically feel the full effect of gravity as if you are on the surface of the Earth. Now, I want to make a quick note here, and I will elaborate more on this in upcoming videos. But time is the interaction of matter and energy, and space or dark energy. So, the more space or space time, which is actually dark energy, the more time. So, that's why when you are 1000 miles above the surface, you have more time because space and dark energy are the same thing. When you have more space, you have more time, and hence space time, if gravity if gravity is matter pushing away space time or dark energy, and it's dark energy pushing back against matter, you can say the more dark energy or space time, the more time, and the less dark energy or space time, the less time. So if you are near a black hole, there will be a lot of quote unquote gravity, but that would mean that the black hole is actually pushing a lot of space time or dark energy away from itself. And so there will be less tick rate around the black hole, and so there will be less time on the other hand. On the other hand, if you are in the deepest voids, In outer space, there will be no major matter pushing away space time or dark energy, and therefore there will be more tick rate, and so there will be more time. So, time is the interaction of energy or matter and dark energy or space. So, more space or dark energy interacting with matter equals more time. So, how do we quantize gravity? We quantize gravity by dividing it into 10 different substances, right? Because that is what the universe is doing. The universe is actually a multidimensional multiverse, meaning each universe within this cascading multiverse has its own self contained dimensions, any dimensions, right? So, I'm not going to go into crazy trying to explain this in great detail right here, right now. But imagine every black hole, especially the supermassive black holes, imagine they lead to their own dimension, their own universe. Their weight has become too large for this universe, or this dimension they have fallen or ascended into their own new universe. So they have their own version of the Big Bang, and all the matter and energy within them decompresses like a balloon. Energy becomes matter, and dark energy becomes space. A rapid hierarchy of pressure zones forms. This is based on the actual structure of dark energy mathematics and geometry, which I will elaborate on more in other videos. But for now, imagine the black hole leads to its own universe, and that universe divides its dark energy into 10 distinct pressure gradients. So imagine we are in a universe that is a black hole in the universe above us. We had our Big Bang, and the universe went through what is traditionally called inflation and then solidification. When the universe solidified, this is the point where the 10 pressure zones equalized enough to actually form what you would call surface or surface area. The first 5 pressure zones, or the first 5 states of quantum gravity, the very large and the second set of pressure zones, the very small, meet in the middle and start to interact with each other. This is solidification, and this is the surface. And the surface is formed up by the stars and the planets. The matter of the universe is where it matters, and that is at the middle of the very large and the very small. And this is the surface that makes up all matter. So I'm going to try to keep this very simple, and I have already spelled out the 10 layers of quantum gravity, with one being the black hole we are entangled in, and 10, or it's actually 0 plus 1 or 1 plus 0, being a new black hole leading to a new universe. So I'll try to keep this simple. To keep this simple, we will think about 5, as this is the surface, right? On what we are, our surface is 5, okay? And this is the state of quantum gravity that forms up the whole cosmos. So what is cosmos? Cosmos is defined as the universe as a well ordered whole. The universe is not random nothingness. Even if you try to randomize randomness, you get some structure, right? And the universe is in fact a very well structured construct. Get it? Universal construct, state 5 of quantum gravity, is the actual cause of the cosmos, the stars, planets, moons, protoplanets, surface of matter. Alright, whatever you can see, whatever which is visualized and tangible and you can touch, right? All of that is state 5 matter. So in the universe, all matter is decaying, right? Back up the elemental chain from iron to hydrogen and then back into light itself. And light is literally electromagnetic energy, and eventually, this electromagnetic energy becomes dark energy. This is the decay of all matter in the universe. Matter can exist outside of solar systems, but not for long. In cosmic terms, as it will tend to evaporate. Think of it like a cube of ice in your freezer. Have you ever made ice and not used it for about a year, and all that is left is little pebbles at the bottom of the ice cube trays? Matter is similar. Matter that is not enveloped in a major gravitational field will evaporate like ice in a freezer. Again, this is in cosmic terms. So, if a small asteroid gets flung out of the galaxy into the void, it will shrivel and decay into nothingness. Eventually, if it takes a billion years, there is very little matter outside of galaxies and in between the stars. I will go over the decay of all matter more in an upcoming video. So, state 5 of quantum gravity is the star and the electromagnetic energy that creates a bubble of influence around it, which is referred to as the heliosphere, defined as the region of space encompassing the solar system, in which the solar winds have a significant influence. Outside of the heliosphere, there is more dark energy, more space time than inside of the heliosphere. If you were on a planet that was outside of the heliosphere, would you experience an hour the same way you would if you were on Earth? No, the heliosphere is a giant bubble of electromagnetic energy surrounding the star and what is considered to be the entire solar system. There is a very distinct transition between the inside and the outside of the heliosphere. So, Voyager, the space probe which was launched from the Earth 50 years ago, so when Voyager was passing through this region of the heliosphere, it was showing, which was when Voyager passed the boundaries of the heliosphere, it showed some starting anomalies. What were the startling anomalies? So, to the science team, because the heliosphere, you see, is not a solid line in the sand, but more like the water rising and falling on the sandy coastline. Voyager and its journey out of the solar system actually went out of the heliosphere and back into the heliosphere many times. And guess what happened to the signal? You guessed it right. As the line fell and exposed Voyager to interstellar space, meaning it was outside of the heliosphere, its signal almost doubled and it sounded like the modem switched to overdrive. But when the wave overtook Voyager and Voyager was back in the heliosphere, the signal normalized and had its regular sound pitch. As the craft left the solar system, there was a quantum leap in its time. Its time increased by almost double. And when it came back into the solar system, its time normalized. The reason we heard the sound at twice its normal pitch is because its time compared to us doubled from Voyager's perspective. Compared to us, doubled. So, from Voyager's perspective, nothing changed. But because its time doubled, the standard signal it was sending sounded compressed to us. Because we were now in a time zone much slower than it, there is a quantum shift in space time or dark energy around the heliosphere, just like if we look at the surface of the atom. Now, let's turn our focus to inner space. What do we see when we look at the atom? The atom is the six states of quantum gravity. And just like the heliosphere, it creates a distinct bubble around itself. The atom looks solid, but we know it's 99% empty, right? Empty space. So, how could something that looks solid be made of so little? And what is this idea about superposition, right? In class 7th and onwards, we have studied about superposition. So, superposition, the atom and all the little moving parts, they are in a superposition, meaning that each part of the atom is in each possible place it can ever be at any given time. Think about this. The atom is made of almost nothing, yet it looks solid, and it is in what we call a superposition. Yet we know the atom is not stationary. We know the atom is in constant motion. So, this superposition is the parts of the atom moving really, really fast from our perspective. Alright, the atom is moving very fast from the atom's perspective. We are moving very slow. This is the basic idea behind quantum gravity. The galaxy creates a bubble around itself and it has its own time. Alright. The sun, outpowering all the planets, creates a bubble around itself and its solar system. And the atom creates a bubble around itself, and the protons, quarks, nuclei all do the same thing. The atom is state 6 of quantum gravity. The stars, planets, moons, and protoplanets are state 5 of quantum gravity. State 4 of quantum gravity is the bubble of electromagnetic decay around the galaxy that creates a bubble around the galaxy, and this is referred to as dark matter or the dark matter state of quantum gravity. So, state 3 of quantum gravity is the void, that is currently this is currently referred to as quote unquote dark energy or the dark energy state. There are bubbles of nothingness pushing the galaxies apart. State 2 of quantum gravity is the wormhole from our universe to the universe above us. This may in fact be visualized as the largest expanse of nothingness in the entire universe. This may even be the center of the universe, and we may have already found it. State 1 of quantum gravity is the actual black hole we are entangled in. In the universe above us, again, I will get into the dynamics of the interaction of matter and dark energy, all the states of quantum gravity in more detail in forthcoming videos. But this is the basic idea of quantum gravity, and with this, you will probably have a lot many questions. So stay tuned. I'll work on more videos about dark energy, quantum gravity, and the structure of the universe. Thank you for watching. Stay tuned.